Hello, this is Mr. Bess. Welcome to Chapter 5 Homework Questions. We're going to do questions 6 through 11 on this video. What if the data for Lenny and George from problem 5-1 match the data in each table below? Assuming that the growth of the rabbits multiplies as it did in problem 5-1, complete each of the following tables. Show your thinking or give a brief explanation of how you know what the missing entries are. So based on the core problem 5-1, we looked at the growth of rabbits and how they multiplied. So if you look at the question A here, we have 0 months to 4, and the rabbits go 4, 12, and 36. So from what we had seen before in terms of rabbits multiplying, this is 4 times 3, 12 times 3 is 36, and then we just continue this pattern. So 36 times 3 is 108. And then 108 times 3 is 324. So that's how we're able to find those missing values. And part B, once again, month 0 to 4. Now this one's a little bit harder because you're missing the next number. But if you go from 6 to 24, it's being multiplied by 4. So what do we do on the in-between? Same thing here. 24 times 4 is 96. So if we want to kind of work in the middle there, what if we decide, instead of multiplying by 4 to get 2 away, what if we just multiply by half of that, which is 2? So 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. And 48 times 2 is 96. So that's how you can kind of complete the table. Once again, we are looking for the rabbits in terms of multiplying by some constant value. Question 7. Solve the following system of equations algebraically, then graph each system to confirm your solution. So this goes back to Chapter 4 on solving systems. On A here, we will use the method of substitution because we can take 3y minus 5 and substitute it into x for the first equation. So that'll give us 3y minus 5 plus y is equal to 3. Remember, everything else stays the same. So that's what we substituted in. We can combine our like terms. That's 4y minus 5 equals 3. Add 5 to the other side. 4y equals 8. Divide by 4. And y is equal to 2. And then we can plug that back in. So x is equal to 3 times 2 minus 5. 6 minus 5 is 1. So our solution is 1, 2. And then it says, then graph each system to confirm our solution. So if we graph the equations, we're probably going to want to rewrite these in slope-intercept form. So this would be y equals, if you subtract x to the other side, it would be negative x plus 3. So y-intercept at 3. And a slope of negative 1, so it's going down 1 over 1. So there's your slope of negative 1. And then the other equation is solve for x, but we need to solve it for y. So let's add the 5 to the other side. So x plus 5 equals 3y. Divide everything by 3, and we get y equals 1/3 x, because there's a 1 right there, so 1/3 x plus 5/3. Now, that's actually not very good to graph or easy to graph, so I think what I'm going to do instead, since that's not really a nice y-intercept, I'm going to go back to this and just create 2 points. So I'm going to plug in a value for y. I'm just going to plug in 0. If I plug in 0 for y, that's 3 times 0, and then 0 minus 5 is negative 5, so that means x would be negative 5. And then I'll just plug in x's or y's 2, and if I plug in 2, I get 6 minus 5, which is 1. So that gives me 2 points to plot. 1, 2, which is actually a point already on the line, so there's our solution, and then negative 5, 0 is right here. And so you can see kind of what that slope is. Looks like I'm going up to 1, 2, 3, 4, 5, 6 over 6. So 2, 6 would be 1/3. So I go up 1, to the right 3, so I get a couple more points on here. Graph that line, and then there's our solution, 1, 2. For question B, once again, it's set up for substitution. We can take the negative 2x minus 4 and plug it in for y. Be careful because it's x minus y, so it's x minus that quantity. And we get x minus the quantity negative 2, x minus 4 is equal to negative 5. And then we have x plus 2x plus 4. We're distributing that negative sign to both of them. Combine your like terms. Subtract the 4. And then divide by 3. So x is equal to negative 3. Once again, we can plug that back into the second equation. Y equals negative 2 times negative 3, which we're replacing with the x. And so 6 minus 4 is 2. So our solution is negative 3, 2. And so if we graph this one, we'll go ahead and graph the second one first because it's in the form we need. So our y-intercept is negative 4, and our slope is negative 2. So I'm going to go down 2 to the right one, or up 2 and to the left one. So get a couple more points here. And then graph that line. And then on the second equation, the first equation, x minus y equals negative 5. If I subtract the x, but then I have to divide everything by negative 1, y is equal to x plus 5. So I'll graph that one, plus 5, and then a slope of 1. So up 1 over 1, or I can go down 1 to the left 1, and it looks like it'll intersect right there. And that point should be the point that we had before, which is 1, 2, negative 3, 2, so it does verify what we got before. So that's how you can solve a system using substitution and then graphing them and checking to see where they intersect. On question 8, for the function f of x equals 6 divided by the quantity 2x minus 3, find the value of each expression below. So on part A, we're looking for f of 1. So wherever there's an x, we're going to replace it with 1. So that's 2 times 1 minus 3 in the denominator. So that's 6 over 2 minus 3, which is negative 1. So 6 divided by negative 1 is negative 6. I'm going to rewrite this. F of 1 equals negative 6. So when the input is 1, the output is negative 6. On B, we're looking for f of 0. So we're going to do exactly the same thing, but we're going to plug in 0 for x, and that's 6 divided by 0 minus 3, or 6 divided by negative 3, which is negative 2. So f of 0 equals negative 2. When the input is 0, the output is negative 2. Question C, f of negative 3. So we're going to continue to do the same thing here each time, is plug in negative 3 for the x. So 2 times negative 3 minus 3. 6 divided by negative 6 minus 3. Or 6 divided by negative 9. If you divide that by 3, that'll give you negative 2/3. So f of negative 3 is equal to negative 2/3. Leave it as a fraction, because if you try to change it to a decimal, it's repeating. Moving on to D, 1.5. So f of 1.5 is equal to 6 divided by 2 times 1.5 minus 3. And so we have to simplify the denominator each time. 2 times 1.5 would be 3. So 3 minus 3, 6 divided by 0. And we cannot divide by 0, so therefore on this one, f of 1.5 is undefined. And what that means is, what we talked about before, is that means that's not part of its domain. You can't, that's actually the only number you can't plug in for x, because you can't divide by 0. And then the last one here, it says what value of x would make f of x equal to 4. So now we're saying 4 is equal because this is replaced with the number 4. It's the output. 4 is equal to 6 divided by 2x minus 3. And so to solve this one, we can get rid of the denominator by multiplying both sides by 2x minus 3. So 4 times 2x minus 3 is equal to, now this 2x minus 3 cancels with that, so that's just equal to 6. Distribute, and then just solve, add 12 to the other side, and divide by 8, and we get 18 over 8 reduces to 9/4 or 2.25. So x is equal to 9/4. You can write it as 2 1/4, or you could go to a decimal on this one because it does terminate. So any of those three would work. And so that's how you figure out what the value of each expression is below. Most of them are asking for the output, but E is asking on that one. It's giving you the output, asking for the input. Question 5-9. Benjamin is taking Algebra 1 and is stuck on the problem shown below. Examine his work so far and help him by showing and explaining the remaining steps. So the original problem that he is trying to simplify is 3a to the negative 2b raised to the third power. So we're going to examine his work so far and help him by showing and explaining the remaining steps. So far, because the whole thing was raised to the third power, he has written it out 3 times, which is perfect. So everything inside there gets multiplied by itself 3 times. So now that we've expanded that out, now you have 3 times 3 times 3. So that's 27. So we're taking the 3 times the 3 times the 3. Then you have a to the negative second times a to the negative second times a to the negative second. So you'd add those up and get a to the negative sixth. And then b to the first, b to the first, and b to the first. Add those up and get b to the third power. Now the only problem is we do have a negative exponent. So we do need to simplify that. Remember, reciprocal. So 27, b to the third, nothing changes there. And then the a to the negative 6 goes to the denominator and becomes a to the positive 6. So the quantity 3a to the negative 2b, all raised to the third power, is equal to 27b cubed divided by a to the 6th power. Question 10, simplify each expression below, assuming that the denominator in part B is not equal to 0. So, first one, we have x cubed times x to the negative second. So since you are multiplying, you add the exponents, which would just be x to the first power. And we have no negatives to worry about there, so we're good. And you could just write it as x. You don't have to write it as x to the first. On b, you have y to the fifth divided by y to the negative second. Now you could move y to the negative second to the top, but if we just use our rule of subtraction, 5 minus a negative 2, that would be y to the 7th power. And it works either way. So you could also move the y to the negative 2 to the top, and then you'd have y to the 5th times y to the 2nd, which is y to the 7th as well. On C, we have 4 to the negative 1st power, so we do reciprocal. That's 1 over 4 to the 1st. So you could say it is 1/4, or on this one, change it to a decimal if you want, 0.25. And then the last one, D, we have 4x squared raised to the third. So just like the previous problem, we can expand this out 3 times, and this will allow you to see it maybe a little bit more clearly. So it's 4 times 4 times 4, which is 64, and then x to the second times x to the second times x to the second. You add those up and get x to the 6th power. And so 4x squared, that quantity cubed, gives you 64x to the 6th power. And the last question for this video, question 11. The equation of a line describes the relationship between the x and y coordinates of the points on the line. Plot the points and draw the line that passes through them. So I'm going to stop right there. Let's go ahead and plot these points. 3, -1, 3, 2, and 3, 4. And draw the line that passes through them. So we will do that as well. Alright, so that is a vertical line. You can see, state the coordinates of 2 more points on the line. So we can pick any 2 points, doesn't really matter. I'll take this one at the top here, should be at 3, 10. And then another one is going to be at 3, we'll do 3, negative 4. And as long as you have an x value of 3, anything's going to work there. Then answer this question. What will be true of the coordinates of any point on this line? Well, we just kind of said that. So any x value, all x values will be 3, and then the y can be whatever. Now write an equation that says exactly the same thing. Do not worry if it is very simple. If it accurately describes all the points on this line, it is correct. Okay, so let's also, once again, make sure we say all points on this line have 3 as an x coordinate. Okay, so I want to make sure what will be true of the coordinates. I want to make sure I answered that question right there. And then now we want to write an equation of a line. Well, if all points on this line have 3 as an x coordinate, then to write the equation, we can just say that x will equal 3. Once again, the y value can change, but x will always be 3. B, plot the points 5, negative 1, 1, negative 1, and 3, negative 1. So I'm going to change colors here. So we'll go 5, negative 1, 1, negative 1, and negative 3, negative 1. What is the equation of that line that goes through these points? So the first one, we were dealing with a vertical line, and these values were all at x equals 3. Now we're dealing with a horizontal line, and these values are all at y equals negative 1. Think about that. What is the slope of this line? It's not steep, it's flat, so the slope is 0. So you have the slope, you also have the y-intercept at 0, negative 1. So does that equation make sense at y equals negative 1? So B's equation is y is equal to negative 1. If we include what we just talked about with the slope and the y-intercept, look what the difference between those two. This one is not simplified because 0 times x is 0. So they're exactly the same equation. So that is B. Now C, choose any 3 points on the y-axis. What must be the equation of the line that goes through those points? So we're going to pick 3 points on the y-axis. So here's the y-axis, so pick any 3 points. So I chose 0, 7, 0, 4, and 0, negative 8. What must be the equation of the line that goes through these points? So once again, look at your x values. They're all 0. This is also a vertical line like the red one next to it. And so we would write the equation as x is always equal to 0. So look at what we've just done there. Look at the horizontal and the vertical lines. Look at the similarities between our 2 vertical lines and then our horizontal line, which is at y equals negative 1 or y equals 0x minus 1. So once again, look at the similarities and the differences between those 2 types of equations and 2 types of lines.